In this video, we're going to dive deeper into deep learning. So we went over in the previous videos an overview of what machine learning was and how that works. And so now we're going to go over deep learning and how this functions and how this is extremely powerful. And this is pretty much going to be the future as far as how we're able to create machines, right, that are able to learn on their own without having to be programmed, right? Because we're using something called artificial neural networks. And so let's go ahead and jump into what deep learning is. So deep learning is a machine learning technique that teaches computers to do what comes naturally to humans, right? Learn by example. So if we look at the right-hand side here, we can see that the deep learning is essentially a part of the artificial intelligence hierarchy, right? You have AI, which is mimicking the intelligence of behavioral patterns of humans, and then machine learning, a technique where a computer can learn from data based on a training model from data sets, right? Where we're inputting data and it's structured data so that the machine learning algorithm can learn from the particular data set, right? And then deep learning, this is a technique to perform machine learning inspired by our own brain's own network of neurons. And so we talked about deep learning being one of the foundations of AI, right? Artificial intelligence, it's kind of a, buzzword that's been thrown around, but it's really more of a hierarchy, right? Of different set of terms, right? And within the AI, there's the machine learning and deep learning, which we just went over. So with deep learning, machines employ artificial neural networks to process information, and the technology is behind the driverless cars that enable them to recognize, different signs on the road, whether it's a stop sign or distinguish between there's a pedestrian or a lamppost or the sidewalk or, whatever that may be, right? It's essentially able to learn and distinguish based on the neural networks, right? And it's similar to the neurons in the human brain. So deep learning allows machines to solve complex problems even when using a data set that is very diverse, unstructured, and interconnected, right? So no matter if it's extremely complex, diverse, highly unstructured, all this data all over the place, the more deep learning algorithms learn, the better they perform, right, with time. Okay, so how deep learning works. So most deep learning methods use neural network architecture, right? The deep refers to the number of hidden layers in the neural network. So you can see here from the right-hand side, the input layer, hidden layers, and then the output layers, right? The hidden layers are the ones doing essentially all the work there for the most part, right? And so neural networks are layers of nodes, much like the human brain is made up of neurons. Nodes within the individual layers are connected to the adjacent layers. And then the neural networks take in the data and train themselves to recognize the patterns in this data. And then they predict the outputs for a new set of similar data. So that's essentially how they're working there within the actual hidden layers and the actual layers itself, right? And in an artificial neural network, signals travel between nodes and assign corresponding weights. Traditional neural networks only contain 2 to 3 hidden layers, while deep networks can have as many as 150. So that's quite a bit there, right? So a lot more, processing, a lot more bandwidth there that is, essentially needed and required. So deep learning models are trained by using large sets of labeled data and neural network architectures that learn features directly from the data without the need for manual feature extraction. So notice how this is all doing it by itself. There's very little interaction with an individual, right? Where with machine learning, you're needing to actually program the machine to do something based off of a certain algorithm, right? And you have to continue to monitor it because it's, maybe sometimes making some mistakes and you need to fix the results, right? You need to fix those problems with this. This is just pretty much running a ton, right? A whole bunch, and it's being able to collect the data. It's being able to learn on its own. And it doesn't need to have, the actual, structured data for it to work, right? It's the neural networks that are doing all the work here. Okay, so what exactly are neural networks? So you can see at the very top, we have the artificial neural network, and then right below that, we have an actual neuron, right? So essentially, neural networks are layers of nodes, much like a human brain is made up of neurons, and it's designed to operate like a human brain. So think about that for a moment, right? This is essentially designed to operate like the human brain, and we know how powerful and how efficient and effective the human brain works, right? We're able to have, different calculations, different actions. We're able to, have things done, within a matter of a second, right? Or even, tenths of a second, because, it's all of these different impulses are going all over the place within our neurons, different messages are being sent, right? And so that's really just how powerful the artificial neural networks are, right? They're mimicking how our brain operates with the various neural networks, right? And so in order for us to really understand how the artificial neurons work, we should know how the biological neuron works as well, right? So just like I mentioned, here on the right hand side, we have an actual neuron, and then we have different parts of the neuron. So the dendrites, these receive information or signals from other neurons to get connected to it, right? And then the cell body is information processing. This is where the information processing happens in a cell body. These take in all the information coming from different dendrites and process that information efficiently and accordingly, right? And then the axon sends the output signal to another neuron for the flow of info. The network starts with an input layer that receives input in the form of data, and then the lines connected to the hidden layers are called weights, and they add up on the hidden layers. Each dot in the hidden layer processes the inputs, and it puts an output into the next hidden layer, and lastly into the output layer. So this is essentially why you need to be able to understand how an actual neuron in the brain works, because that is essentially how these artificial neural networks are working, right? Because they're extremely smart, extremely intelligent, right? They're able to sift through tons and tons of data and be able to find out various outputs, right? And so deep learning applications, what are they? The deep learning has so many different practical applications, right? In businesses today and businesses in the future, right? So we look at some here as far as speech recognition, right? You think about Xbox, Skype, Google, right? A lot of the times, even with like email, I know a lot of times with like G Suite that I use on a daily basis, I'll have somebody send me an email, and then at the very bottom, when I'm looking to respond to the email, it'll have various canned responses there that it will come up with on its own, right? Based off of what the message, was previously sent about. So that's where it's able to read and distinguish what people are saying, and then it helps me come up with canned responses based off of what people are actually looking to find out from me, right? Or what the email is about. So speech recognition can also be going into Google and just going on your phone and saying what is the best XYZ or restaurant near me, or whatever that may be, right? Google will be able to read your speech there and give you a designated or specific type of search query there, right? And so image recognition, one practical application of image recognition is automatic image captioning and scene description. This can be one of those deals in the law enforcement area where they're investigating different criminal activity, different types of photos that are submitted by individuals, right? They're really able to find out who exactly those individuals are, and it helps with the law enforcement there. So very, very powerful. And then we have natural language processing. So neural networks, a central component of deep learning, have been used to process and analyze written text for many years. This is kind of what I was talking about, the natural language processing, right? As far as the emails. This is going back to what I was talking about as far as the emails, right? The speech recognition and the natural language processing. Natural language processing is more for the emails in the written form, while the speech recognition is for more or less when you're on your phone, when you're using your headset, when you're talking into a particular microphone that allows the computer or a particular program to spit out different search criteria, right? Based on what you're telling it through your voice. And then NLP is really where it's finding out different types of written text and analyzing it and being able to give you certain responses as well. So that's going to be here for what exactly is deep learning. That's it for this one, and we'll see you on the next one.